Welcome to this second lecture in module number 3, and this will talk about basic elements of a data warehouse. Recall from the previous lecture on this module, so we had talked about sorry, the animation is a little bit out of place. So in the first lecture in this module, I talked about the source systems and the data marts and supermarts, and the data warehouse and the ODS, that is operational data store. So, and I also discussed about the difference in approaches difference in approaches of Kimball and Inmon, and that is a very important kind of a topic or discussion that everyone should know about, that how these approaches are different, and which ones are more practical and which ones are more technically sound. So all these discussions are very important. So I had discussed that in the previous lecture of this module. So today I'm going to focus on another 3 key components of a data warehouse. So the first one is the data staging area, the second one is the presentation server, and the third one is OLAP. So with this, we'll be able to look at all the basic elements of a data warehousing system, right? And we'll also be able to see the interconnect between them and how they work together in a data warehousing system. So let me begin by talking about data staging area. So this is the architecture. So this I have put just for the sake of completeness. So we can just skip this part, right? So, but what I'll do is I'll highlight. So let me remove the video from here. Yeah. So just for the sake of completeness, let me just tell you where I'll be focusing on in today's lecture. Sorry. Yeah. So I'll be looking at this ETL part mainly. So, and the ETL is generally done on done on the data staging area. In the data staging area, the second part is the data warehouse itself. So that is the presentation server, and then we have this OLAP, right? So analysis and using OLAP. So I'll be talking about OLAP here. So these are the 3 major things that I'm going to talk about. Although we also need to mention about metadata, so that I'll do at some point in the lecture, and we are having a separate module on the metadata repository. So probably I'll touch upon it today, and then when we come to that particular module on metadata, I'll give you all necessary details about the metadata and the role it plays in data warehousing. So let us come to this staging area that is called the data staging area. So let me clear the annotations so that you can read the text properly. So a storage area where extracted data is cleaned, transformed, deduplicated, and it is basically prepared to be loaded onto the data warehouse. And it is the initial storage for data. So as you know that from the source systems and the external systems, the data does not go directly into the warehouse, right? So it is staged, and it is staged in the data staging area, and the data need not be based on relational model, right? So although a mix of relational model and flat file structures are commonly used, and it could be spread over a number of machines. It need not be a single machine, because as you know that ETL, right, is the major task in data warehousing, and it is not possible to do all the ETL on a single machine. So tasks which can be actually executed in parallel are run on different machines, and then it is then loaded onto the warehouse. and it is mainly about sorting. So there is a lot of sorting activities that or sorting operations that are carried out in this process, and a lot of sequential processing that happens. And it is common to have COBOL or C code running against flat files, and this does not provide any kind of data access to the users. And analogy for this is the kitchen of a restaurant. So the end users, which are the customers who have come to the restaurant, they are not allowed inside the kitchen for various reasons. So it's a nice analogy that I'll talk about in more detail. So the data warehouse staging area is a temporary location where data from source system is copied, and due to varying business cycles, data processing cycles, hardware and network resource limitations, and geographical factors, it is not possible to extract all data from all operational databases at exactly the same time. So it is basically a continuing process, right? So as a particular business day ends, right? Say suppose it ends at 5 p.m. in India, right? So it will end maybe it will end later in the Middle East, and then further in Europe, further later in Europe, and so on. So you need to extract data from these operational systems at different times. Say for example, data from Singapore branch will arrive much earlier than the New York branch, right? So then these kind of things will happen, right? So you cannot extract all data from your operational systems at the same time. Okay, so you have to do it at different times. So this is one important point due to different time zones. And what this does is it simplifies when we copy or when we extract the data into the data staging area first, it simplifies the overall management of a data warehouse system. And as I told you, ETL tools work in the data staging area, and DSA is everything between the source systems and the presentation server. Presentation server is the actual data warehouse where the data is made accessible to the end users or to the end user applications that are running. And as I told you, I'll talk about its analogy with the kitchen of a restaurant. So raw data or raw food, so read data, is transformed into fine meal, read data fit for user queries and consumption. And DSA is accessible only to professional chefs, read skilled professionals who are performing the ETL or who have developed the code for ETL for different aspects of ETL, right? And customers, read end users, are not invited to eat in the kitchen. That is, query the data that is there in the DSA. Okay, so I hope you all understand what this means. Okay, so DSA is an area where end users are not allowed, or any kind of query is not allowed. So it's a key architectural requirement for the DSA is that it is off limits to the business users and does not provide query and presentation services. So this is the most important aspect. So this is where you try to prepare your data to be loaded onto the warehouse. And steps involved. So this is nothing but the ETL. So you extract data. So let me just give you some idea about what is extraction. So you don't need all the data that is there in the source systems for the data warehouse. So you have to basically choose what data you exactly need for the data warehouse. So extraction process allows you to do that, and it's a nice interface. It is done using a GUI where you can select different. So you are shown all the tables that are there in the source systems, and I'm assuming that it is working on a relational platform. So you are basically seeing all the tables that are there. So what you can do is you can say that okay, this table, okay, I need it, So once you say that I need this table, then you are asked a query about what attributes you need in this table and so on. And if you don't need a table, you just say that you just remove it from the list. So likewise, you can select tables or relations from the source systems, and also the attributes that are there in those tables. So you can do all that in the extraction phase. So that is the first step in this. And then the second step is transformation. And here you basically perform the cleansing of the data. So you remove any kind of errors or noise points from the data, and combining data from multiple sources, right? So if so you have product codes which are different in different systems, so you have to basically come up with a common product code, right, which is the same across all sources. And you also need to do a lot of deduplication. You need to do a lot of deduplication of data, because duplicate data is not desirable. And we also talk about surrogate keys, assigning surrogate keys. So that is one of the important tasks of ETL, and especially the transformation, where we so as I think I have discussed this earlier, surrogate keys. So these are like not dummy, they are integer keys mainly, and these are 4 byte keys, 4 byte integers, and they exist along with the natural keys. So say suppose the ID number of a student is the natural key, right? So we'll assign an integer to this ID number, and that would be the surrogate key. And in the data warehousing environment, in the dimension tables, both surrogate key and the natural keys, they coexist, right, in the dimension tables. And surrogate key is the primary key for the dimension tables, but the natural keys are also there. And in the fact tables, only the surrogate keys exist. Okay, so so that's how surrogate keys are used, and they play a very, very important role in data warehousing. So let me just kind of remove this. Just wait a minute. Okay, so surrogate keys is generation of surrogate keys is a very, very important task. And then finally we load the data, or we transfer the data onto the data warehouse. So you will come across terms like ETL, which is more commonly used, but you will also see terms like ETT, that is extract, transfer, transform, and transfer, right? So both these terms are used interchangeably. So let me clear this annotation so that yeah. So DSA is dominated by sorting and sequential processing, as mentioned earlier, and it is not typically based on the relational model, but rather a collection of flat files. And what happens many times is that the data arrives in third normal form, because if you know OLTP systems, right, so data is typically normalized, and it is normalized in up to third normal form, right, 3NF as we call it, right? So third normal form, which is acceptable, but it is not recommended, because data has to be loaded onto the presentation server in the dimensional model. So basically it does require some additional efforts on your part, that you convert the third normal form data into the dimensional model. And another aspect of this is that normalized database is in the staging area is acceptable for supporting the staging process, but must be off limits to user queries. So this is another reason why we don't allow any kind of access in the data staging area, because normalization defeats both the understandability of the data, because say logically you design a table which would have all the fields that you require or that are related, but due to redundancy reasons you split it into two or more entities, or two or more tables. So to understand that particular kind of table in whole, you have to look at 3 tables now instead of one table, right? So understandability suffers, And you also know that performance also suffers because of normalization, because you need to perform joins to be able to extract data. So that's why we don't encourage normalized structures into the staging area. And then this brings us to the next part of next important aspect of our data warehouse, that is the presentation server, which is actually the data warehouse. So our target physical machine on which data warehouse data is organized for direct querying by end users using OLAP. So OLAP is the next thing that I'm going to talk about. And you can use any kind of report writers or any visualization tools, or if you want to do mining on the data, so you have the data accessible to you through the presentation server. And since, as I told you in the beginning, that most practical implementations of data warehouses follow the Kimball's approach and use dimensional modeling, right? So we will stick to that, right? Although you can talk about, or you may have to do some implementations using the Inmons approach as well, but most of the implementations of data warehouses use the dimensional framework. So just from that point of view, I'm focusing only on dimensional framework. And presentation area is the data warehouse for the end user. So this is the actual data warehouse, although you have seen that a lot of activities are happening behind the scenes, right, before the data comes to the data warehouse, right? And the analogy for this is the sitting area of a restaurant. So this is where you are served the data or the dish that you have ordered, right? And in Kimball's approach, presentation area is a series of integrated data marts, because it is a bottom-up approach, right? So we first build the data marts under an integrating framework. So it is not that these data marts are basically developed without any coordination between the different data marts. So we call them super marts. So I've already talked about them in the previous lecture. So data mart is a wedge of the overall presentation area pie. So it is just about one business process or one particular division or department in the organization. And data is presented, stored, and accessed in dimensional schema, because that is the closest to the business user or the end user. And dimensional modeling is very different from 3NF modeling, as we have seen, right? Although we'll be talking about some more differences between the dimensional modeling and ER modeling as we go along. And these are also referred to as normalized models, because 3NF is an accepted kind of a normal form, right, which takes care of most of the redundancy related problems, right? Although you can normalize to the Boyce-Codd normal form, right, that is BCNF, right, or higher normal forms if need be. But 3NF is considered to be a good operational system design, right? OLTP design. 3NF is considered to be a good normal form. So we generally refer to them as normalized models rather than calling them 3NF models. And normalized modeling is quite useful in OLTP systems, but they are not suitable for data warehouse queries for reasons I mentioned in the previous slide. The understandability of the of the data is compromised, and so is the performance. So presentation server. So let me clear this. So data marts contain detailed and atomic data. Right, so it is not necessary that data marts always contain aggregated data. So they may contain data that is detailed and atomic, and they may also contain aggregated data. And all data marts are built using common dimensions and facts. So we call them conform dimensions and facts. So this is another very important aspect in data warehousing, that you design dimensions that can and facts that can be used across schemas, across star schemas. So this concept again will come up when we talk about advanced dimensional modeling concepts. And the concept of supermarts I have already introduced in the previous lecture in this module. So Kimball's approach advocates the use of supermarts and not per se data marts, right? So you should understand the difference between a data mart and a supermart. So a supermart basically contains the most granular data, and they are built using using or under an integrating framework, whereas data marts typically contain aggregated data, not the finest granularity data that is available, and they are kind of developed independently of each other. So the concept of supermarts is what Kimball advocates, and these supermarts are. So Kimball also says that his approach is not bottom-up approach, not the typical or the conventional bottom-up approach, because it looks around other data marts also, right, and also looks at the horizontal span, right, which I discussed while discussing supermarts. So the concept of supermarts, when you use supermarts in your architecture, you are making sure that their integration is seamless. And these presentation servers follow the data warehouse bus architecture, and building a data warehouse in one step. Sorry, there's a typo here. So so in one step is too daunting a task, and architected and implemented an incremental approach to building data warehouse is the data warehouse bus architecture. That's what is the bus architecture for data warehouse. That is, you have a proper architecture in place, and you build your supermarts incrementally, that is one after the other, and you can also schedule the most critical ones earlier, and define a standard bus for the data warehouse environment. That is basically the delivery process, right? So so you know the bus in a computer system, right? So same is the concept of bus in a data warehousing environment. So separate data marts developed by different groups at different times can be plugged together and can usefully coexist if they conform to the standard. So that is the main take in this, that because of practical reasons, not all data marts or supermarts can evolve at the same time, right? So they come into existence, or they are developed at different points of time. So the good thing is that they can be plugged into the bus, right? And they can be used to build the data warehouse. They can be integrated to build the data warehouse. So according to Kimball, so data in the queryable presentation area of the data warehouse must be dimensional, must be atomic, and must adhere to the data warehouse bus architecture. So we'll have some more details on this bus architecture when we talk about the life cycle of a data warehouse project. So that would come towards the end of the course. But it is mainly that it's mainly about that you can plug in different data marts or supermarts which evolve at different points of time. So it is not necessary that all the data marts should be ready before you can build the data warehouse. And then I come to the data access tools, which is the last topic for today. So data access tools query the data in the presentation area of the data warehouse, and the most commonly used access tool is OLAP, which stands for Online Analytical Processing. So I'll now be talking about what is OLAP and what is the need for OLAP, what are the features and functions of OLAP, and different OLAP models and implementations. So, but this would be just an introduction to OLAP. So there's a separate module on OLAP which is scheduled later. So that you have, so why I'm introducing all these things at this point of time, so that you have an overall picture of a data warehousing system and some introduction to all the key components of a data warehousing system. So let me just quickly introduce this. So this term was coined in the mid 1990s. Remember that data warehousing concepts or data warehouses became popular in the early 90s. So during the mid 90s this term was coined, and main goal was to support ad hoc and complex queries by business analysts, and this extends worksheet like analysis to work with huge amounts of data in a data warehouse. So worksheet or spreadsheet kind of environment is created, and that is used to express complex queries on our data warehouse. So demand for OLAP, because we need, another thing that I wanted to point out is that if you look at this figure at the top, right, so this typically is a cube, okay, and in data warehousing we call it hypercube because it is typically has more dimensions, more than 3 dimensions, and all your analysis is based on this cube structure. So whenever you read about OLAP, right, so you also talk about this cube structure, which is one of the most important features of OLAP, right? And most of the operations, OLAP operations, can be performed using this cube operator, and this cube operator has been incorporated in SQL also, right? So if you are given a data in a relational format, right, so I can generate a cube out of that, right? So those details will come. And limitations of other analysis methods like SQL spreadsheets and report writers. So since the implementation of data warehouse is typically on top of a relational model, so the kind of queries that you can execute on them is limited by the capabilities of SQL, right? So in one of the later modules I am going to talk about what kind of extensions of SQL have been proposed so that more and more complex data warehousing queries can be executed or can be expressed. And spreadsheets, so there is a very I'm sure all of you have worked with spreadsheets, so we'll extend this concept of spreadsheets to what are called as multidimensional databases. Okay, so spreadsheet, if you look at it, it's a 2-dimensional database. Okay, so we'll now try to extend this 2-dimensional database to multidimensional database, and you'll see that there are lots of implementations of OLAP where some of the data is stored in multidimensional databases, and we refer to that as multidimensional OLAP. So this is one of the flavors of OLAP, right, that is there. And of course, whatever we do using SQL and relational databases, so that is called as ROLAP. Okay, and the mixture, so I take the positives from both ROLAP and MOLAP and have something called as HOLAP. So that is basically the hybrid OLAP, which takes the best of the relational model and the multidimensional model. And of course, this report writers, so they have their own limitations. Okay, so they are basically, they don't do much computations, right? And they just take different data from different tables and put them together into a report. So very minimal kind of calculations are performed by report writers. So what we are trying to see here or do here is that we are saying that SQL may not be appropriate, or it has its own limitations. Spreadsheet is typically 2-dimensional, and report writers also have their own limitations. So to overcome these limitations and to provide users with a very strong tool that can perform any kind of analysis that he or she wants to perform using a tool which is called as OLAP. So OLAP is the most generic term, and as I told you, ROLAP and MOLAP are variants of this depending upon how the data is stored, and HOLAP is a kind of a hybrid model, which is a combination of relational as well as multidimensional model. So I'll just read out some kind of definitions of OLAP so that you understand it better. So there are like not one popular definition. So I have put together a couple of them here in this presentation. So OLAP is a category of software technology that enables analysts, managers, and executives to gain insight into the data through fast, consistent, interactive access in a wide variety of possible views of information that has been transformed from raw data to reflect the real dimensionality of the enterprise as understood by the user. So this is a kind of a long definition, but it conveys the essence, right? And as we go along, you will understand this much better. OLAP software provides the ability to analyze large volumes of information to improve decision making at all levels of an organization. So this is more generic, and a wide spectrum of multidimensional analysis involving intricate calculations and requiring fast response times. So this again illustrates two aspects which are highlighted here in this slide: complex questions, and we want fast answers. So that's the online part of this, right? So online part is not that. So online has different perspectives, right? So here it means fast. So the query that you pose, so whatever, howsoever complex it may be, right? And you want the response to be very, very quick, right? So that is the online aspect. So online here means fast and interactive analysis. And whatever answers I get to my query, then based on those answers I ask another query, and so on. So it is it's a highly interactive system that we are working with. And analytical part, it just says that the queries are very, very complex. So let me so we basically want a separate OLAP tool because it empowers end users to do own analysis and frees up IS backlog of report requests, because I can now generate my own report according to my requirements or whatever I need. I can use an OLAP tool to generate my own reports, and ease of use. And the best thing about it is that you don't need the knowledge of tables or SQL. So it provides you an abstraction, right, which does not require you to know SQL or the schema of all the tables that are there, right? You basically specify what you want, right? And that is provided through an OLAP tool. And OLAP tool characteristics include multi-user environment, and it's a client-server architecture. So typically you have a OLAP server, and multiple users can access this OLAP server in the client-server model, like we do in the client-server model. So you have clients installed, client OLAP installed on the user desktops, and they can access a server. So all the computations are typically done on the server, and rapid response to queries regardless of data size and complexity. So these are like typical characteristics, and something about the architecture. And it works on top of a data warehouse, and it is the most commonly used front-end tool for a data warehouse. And rest of the points are self-explanatory. And it is useful. We have already discussed that. So it facilitates multidimensional data analysis. And one of the things that we do is that we pre-compute the aggregates. So right now I don't think I'll be able to explain this properly because there's no background yet. But if you look at the handout, and so there is one module on query performance enhancing techniques, and pre-computing aggregates is one of the most important, most effective kind of technique for improving the performance of queries in a data warehousing environment. So OLAP provides help for all that and provides for greater speed and responsiveness and improved user interactivity. So now warehouse models and operators. So data models are like relations. So as I told you, all these dimension and the star schemas are implemented as relations, and there is also these structures called as cubes, which are typically related to a multidimensional database, but we talk about these cubes in a relational environment also. And we'll be talking about cube computations and efficiently computing cubes in the later modules. And then if you talk about operators, so there are something called as slice and dice, roll up and drill down, pivoting, and there are lots of others. So these are typically supported by any OLAP model. So I'm right now not going to talk about these, but let me give you some idea. So slice basically, say if I just cut this cube here, right, so I get a slice, right, so that's a slice. Dice means I take any subcube of this, right, so say like I can take this cell along this slice, and this cell along this, so this is subcube, right. So any kind of subcube that I draw from here, not necessarily contiguous, so that is a dice operation. Roll up and drill down is typically, roll up means you hide information, and drill down you add information, that is more and more information, right. And they are typically done using they are typically done along hierarchies. So suppose I have yearly data. Okay, so from yearly data, suppose I want monthly data, right? I want to break it up into months, and then I want to break it up into days. So when I do this, so I'm doing what is called as a drill down, and the opposite, if I go in this direction, I'm doing a roll up. So this is a typical roll up and drill down operation along a hierarchy. But without hierarchies also, when you add any piece of information to the data or to a particular report, so you are doing a drill down, and when you hide some information, you are basically doing a roll up. Pivot is basically seeing different views of the same data. So suppose I am seeing this view of the cube, so if I rotate it by 90 degrees, so I see another view of the data, and then there are whole lot of other operations that you can perform using an OLAP tool. Now before I end this lecture, let me give you the complete picture. So the complete picture is sorry about the so you start with the source systems. These could be the internal source systems or the data that you buy or get from external sources. So all of them combined are called as the source systems. And then data is extracted from the source systems and put in the data staging area, where it is cleaned, transformed, and prepared to be loaded onto the presentation servers, right? And then these are data marts or super marts. So for building any data mart or super mart, you have to work with the source systems and the data staging area, right, to build a data mart or super mart. And then this is the warehouse, and operational data store is basically somewhere between the source systems and the data warehouse. It is not there typically in the in a conventional data warehousing environment, but some organizations develop this operational data store for a different purpose, and it can be used to feed the data warehouse, right? So if it is there, you use it. If it is not there, don't worry about it. If your goal is to build a data warehouse, and then you have the data access tools, which are like typically we talk about OLAP or some kind of data visualization tools or data mining tools. So these are all end user access tools or report writers. Okay. So what we need to do is we need to understand the interconnect between the above elements of a data warehouse system. So we should see that how the data flows from the source systems to the data access tools, and what role these intermediate things or intermediate components or pieces play while transferring data from source systems to making the data available or accessible to the data access tools. So that is what was the objective of this particular module, to expose you to the different aspects or different components of a data warehousing system. So with that, I conclude this module on elements of a data warehouse, and I'll I'll be talking about each of these components separately in later modules. So with this, I end today's session, and I'll be starting module 4 shortly, and that will be made available to you. Thank you.